Okay guys, in this video we're going to be looking at solving quadratic equations, but specifically by using the graph of the quadratic equation. So very quickly here, let's recall that anything that we consider to be a quadratic equation is an equation that could be written in this form right here, where we can see the standard form of our quadratic, and specifically it is set equal to 0. So one thing I want to remind ourselves of is this: we are setting really y equal to 0 here. And so graphically speaking, what we see is that we're really looking for the points on our graph where it's at a height of 0, which would be, as we typically call them, the x-intercepts. And so the solutions that we're looking for here are the x-intercepts of the graph, the x-intercepts, but we also give those a name in math in an algebra class here, but we usually refer to those as the x-values that cause our function to be 0. In other words, the zeros of the function here. So we can see that this graph here in particular that I've drawn has a couple of zeros, but these are the x-values that when I plug them in my function give us an output of 0. So in other words, again, the x-intercepts of the graph are the solution values for this equation up here. And so what we're going to do is we're going to, first things first, set this equal to 0 if we're going to solve this by graphing. And I'm going to accomplish this by, maybe I'll carry the 8x over to this side here. And so what I'll do is I'll subtract 8x from both sides. And actually I'll show my work here, minus 8x. But what I would get then, actually, let me get the 0 out of the way. So we subtract 8x from both sides. Is I would get this new equation where I got 0 equal to, and I'm going to put my negative 4x to the second up in front, and then I'm going to put my minus 8x there, and then I'm going to put my minus 4 here. You'll notice that this is in standard form, and of course set equal to 0. So this is the quadratic equation that we're going to go graph. And so let's go ahead and take a look at how we would go graph this. Of course, since it's in standard form, the very first thing we're going to do is find our axis of symmetry here, which is always at, remember, negative b over 2a. So in this case, our b value is a negative 8, and our a value is a negative 4. So when we simplify this, what we get is a negative 8 on top, and on bottom we get a negative 8. So in other words, we get negative 1, which is this vertical line that is our axis of symmetry of this parabola here. So I'm going to go ahead and sketch this in, as a matter of fact. I'm going to say, okay, well, I know first of all that our parabola is symmetrical about this line, x equals negative 1. So now if we want to find the vertex value, I suppose what we'd have to say is, well, it has the same x value, we need to go find the y value in order to do this here. So what I'm going to do is I'm going to go ahead and make my table as we do, and I'm going to plug in negative 1 for an x value and see what we get for an output value. So I would plug this in, I would get negative 4 times input squared minus 8 times input minus 4, and our input here is negative 1. So going through our order of operations here, we'd have to do our exponents first. When we square a negative 1, we'd get a positive 1. Here, a negative 8 times negative 1 is a positive 8, so I'm going to say plus 8 and then minus 4. This actually ends up giving us negative 4 plus 8 minus 4. So negative 4 plus 8 is 4, and 4 minus 4 is 0. So what this means is this graph has a point right here at 0, or negative 1, 0, and that is its vertex. And furthermore, looking at the a value up here, it looks like we have an a value of negative 4. I'd go right 1 and 1, 2, 3, 4, down 4 here. And because of symmetry, know that the left side of my graph exists here. So without going into plugging in any extra values here, because I can already see that I see the solutions, what I want to look at is just basically what is our solution here. And so what we see is that we have one x-intercept, and we say at x equals negative 1. And so in terms of the solution to this equation right here, what we would just simply write is this. Well, if you wanted to solve it, then we would just go look at the graph, and according to the graph, the solution only exists at negative 1. And so only one solution, and that is at its vertex. But essentially, what we want to keep in mind is this. When we are solving these quadratic equations, oh, I can just put it right here. What we're looking for are the x values that when we plug them in cause our function to be at a height of 0. So we are looking for their x-intercepts. And it's good to keep that in mind if you ever have the graph of your function. We can check your algebra against the graph's x-intercepts. Cheers.